So now for this video, we're going to go back and review everything quadratics to get ready for our upcoming quiz. So to start with, we solve by using the quadratic formula. Recall the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now before we find a, b, and c, we want to make sure it's set equal to 0. So for this example, I'm going to subtract the 5 over and get 2x squared minus 11x plus 2 equals 0. Then my a is 2, my b is negative 11, and my c is 2. So then I'm just going to plug in. So a negative b would be a negative 11, or a positive 11, plus or minus the square root. My b squared is 121. Remember, b squared is always positive. Minus 4 times 2 times 2, all over 2 times a, or 2 times 2, which is 4. This is going to stay negative, and 4 times 2 is 8, 8 times 2 is 16, and 121 minus 16 is 105. So I have plus or minus the square root of 105 all over 4. 105 is not a perfect square, so we want to try to break it down. So if I think about my factors, obviously 5 goes into it because it ends in a 5, and that's 5 and 21, and then 3 and 7 go into 21. I have nothing to circle, so I can't take anything out or simplify my radical, so I'm going to leave it as 11 plus or minus square root of 105 all over 4, and that is my answer. Then we also solve by completing the square. So completing the square means I'm trying to write it as a perfect square trinomial so that then I can write it as a binomial squared and solve by square roots. Okay, so again, the first thing I want to do is go ahead and get my constants on the same side. So I'm going to add the 11 over and get 13. And I can't complete the square until I get rid of the a. I need my a to be 1. So I'm going to divide everything by 2. So on this side, I'm going to get x squared minus 3x. I'm going to go ahead and add in the box. Equals, and I can't simplify 13 over 2, so I'm just going to leave it as 13 over 2. We've got to work with fractions. To figure out what goes in the box, I'm going to do b over 2 squared. So then half of 3 is 3 over 2. And then 3 over 2 squared becomes 9 over 4. So I have a 9 over 4 that goes in the box. All right, I can rewrite this side as x plus or minus b over 2. So it's going to be a minus because my equation started with a subtraction. And then b over 2 we said was 3 halves. Squared equals, all right, to combine 13 halves and 9 fourths, I need a common denominator, which is going to be 4. So I'm going to times the top and bottom of this one by 2. So we get 26 over 4 plus 9 over 4, and that's going to be 35 over 4. And then I'm going to take the square root and start getting x by itself. So I have x minus 3 halves equals, I can't take the square root of 35, so I'm going to leave that. But I can't take the square root of 4, so I'm going to put a 2 on the bottom. Then I'm going to add 3 halves to both sides. And I can rewrite this with the 3 halves first as 3 halves plus or minus root 35 over 2. And they both have the same denominator, so I can combine it and say 3 plus or minus root 35 all over 2. Now again, you should be making sure that you can't simplify that radical anymore, but if I were to simplify the square root of 35, the only thing that goes into 35 is 5 and 7. So again, I can't simplify it, so we'll leave it as a square root of 35. And then this is my answer. We also did a lot of factoring. All right, remember the first thing you always want to look for is a GCF, your greatest common factor. So for my first one, I have 4, 6, and 12 for my coefficients. So my GCF of those is going to be a 2. And then they all have x, y, and z. So I'm going to take the smallest exponent, which happens to be x to the first, y to the first, z to the first. So my GCF is 2x, y, z. Then I'm going to divide everything by that GCF. So 4 divided by 2 is 2. X squared divided by x is x, y to the 5th divided by y is y to the 4th, and then the z's cancel. Negative 6 divided by 2 is negative 3. The x's cancel. We get 3 minus 1, or y squared, and 4 minus 1, or z cubed. 12 divided by 2 is 6. My x's cancel, my y's cancel, my z's cancel, so I'm done. Remember, you're going to have the same number of terms in your parentheses as what you started with. And then they should have nothing in common. So 2, 3, and 6, we can't take anything else out. They don't all have x's, y's, or z. Okay, if we have 4 terms, we're going to think grouping. But again, look for your GCF first. 8, 28, and 2 all have 2 in common, but that 7 messes us up. So my next step is just to split it down the middle. The GCF of the left-hand side is 4, and then x squared. So if I take out a 4x squared, I'm left with 2x plus 7. And then over here, I think this is a typo. I think that should be a minus 2. So you have a negative 2x minus 7. So there's nothing in common, so it's a 1. But remember, you always take the sign that's out front. So this is a negative 1. And then it becomes a positive 2x, positive 7. You know you're on the right track if your parentheses are the same. So then my two parentheses become 4x squared minus 1 and 2x plus 7. Okay, remember, look to see if you can keep going. That 2x plus 7 is done. The 4x squared minus 1, I could do difference of squares. So my square root of 4x squared is 2x. Square root of 1 is 1. So we get a 2x plus 1, a 2x minus 1, and then a 2x plus 7. And that is fully factored. Okay, speaking of difference of squares, we're going to come back to this one. 4 and 9 are both perfect squares. Even exponents mean it's a perfect square. So the square root of 4x to the 10th is 2x to the 5th, and 9y squared is 3y. So I get 2x to the 5th plus 3y, 2x to the 5th minus 3y. And then over here, I know that I have an 8th power, right, which again is an even number. So if I take out my GCF, because 2 is not a perfect square or 162, it becomes x to the 8th minus 81. Right, then my square root is x to the 4th and 9. So I get 2 times x to the 4th plus 9. And then x to the 4th minus 9. Remember that 2 is still part of my final answer. All right, I can't do anything with this first part, but x to the 4th minus 9, once again, perfect squares. So I have 2 times x to the 4th plus 9. That doesn't go away. Then this parentheses breaks down to x squared plus 3. X squared minus 3. All right, now I didn't put any perfect cubes in here, but remember the cube pattern. If I had something like a cubed plus b cubed, right, find your cube root, right, then we have a little parentheses and a big parentheses. We take our cube roots and put them in a little, then we square the first one, multiply them together, square the second, and then we use SOAP. So same sign, opposite sign, always positive. It's all dependent on what sign you start with in your original problem. And then we factor trinomials. So the first one here, x squared minus 10x plus 9, that's a plain Jane because it's a equals 1. Right? So these are the easy ones. I can go straight to my parentheses, and I want to multiply to c, add to b. So I want two numbers that multiply to positive 9, but add to negative 10. All right, now remember, for a positive number, you either have two positives or two negatives. And in this case, because I'm adding to a negative, I'm going to have two negatives. That's the only possibility. And so I have 3 and 3 or 1 and 9. So the 1 and 9 is what's going to get me to a negative 10. For this one, always look for your GCF first. I have a GCF of 2. So that leaves me with 5x squared plus 6x plus 1. And this one's not a plain Jane because of that 5. So I'm going to do bottoms up to be able to factor this one. So I'm going to take my 5 and move it to make it part of C. So I have x squared plus 6x plus 5. Now I want to multiply to 5 but add to 6. So that's going to be 5 and 1. Those are my only factors of 5. Now I'm not done. This is factoring the plain Jane. I'm trying to factor the not plain Jane. So I got to take that a back out. So I'm going to divide both of these by 5. So I can simplify 5 over 5 and get x plus 1. And this one, 1 over 5, I can't simplify, so I'm going to go ahead and do bottoms up, and we get 5x plus 1. Now this is not my final answer because I took out that GCF in the beginning. That's got to be in my answer too. So I'm going to put that 2 back out front. So then my answer becomes 2 times x plus 1 times 5x plus 1. If I wanted to solve by factoring, this is where I would set all of them equal to 0. Now 2 will never be 0 because it's 2. So that means I don't have to use that whenever I'm actually solving. So I'm just going to take the x plus 1, set it equal to 0, the 5x plus 1, set it equal to 0. So then I get x equals negative 1, and then this one's going to be negative 1/5. And then we graphed our quadratic. So we did standard form and vertex form. So this one's in standard form because I have x squared plus bx plus c. So to graph it in standard form, we always start by finding the axis of symmetry, which is negative b over 2a. So negative b is negative 16. 2 times a would be 8. So my axis of symmetry is at negative 2. So that's the middle of my graph. My vertex is on that axis. So to find the rest of my vertex, I'm going to plug in my -2 into my equation. So we get 4 times -2 squared plus 16 times -2 plus 10. -2 squared is 4 times 4 is positive 16. 16 times -2 is -32, and then a plus 10. 16 minus 32 is -16, plus 10, -6. So my vertex is at -2, -6. So I go here, 2, 3, 4, 5, 6, put my point. Another easy point to get is your y-intercept, which is always the c value. So my y-intercept is 10, which is up here. Then to get my third point, I'm just going to reflect it over because our parabolas are symmetrical. All right, remember the domain for every quadratic is all real numbers. And the range for this one is going to be from my minimum value up. So my minimum was at -6 with a bracket, and it goes up forever, so it goes to infinity. In vertex form, it's called vertex form because it gives us the vertex. So I've got -5, -3. Remember the x value is always opposite. I don't know what happened to my graph. So we'll draw one. So I'm going to go to -5 and -3 and put a point. And remember in vertex form, we're only given that one point, but anytime you want to find a point, you can plug in x to find y. So if I plug in x, I'm going to pick one that's nearby so it doesn't shoot up or down really fast. So I'm just going to plug in -4. So -4 plus 5 is 1. 1 squared is 1 times 2 is 2. And then 2 minus 3 is -1. So I have a point at -4, -1. Remember the vertex is in the middle. It's on my axis of symmetry, so I can reflect that point over to this side. And there's my u. Domain is always all real numbers. Range -3 to positive infinity. And then we graphed our inequalities. So inequalities we're going to graph the same way, and then you can plug in a test point to see where you need to shade. So this one's in standard form, so I'm going to start by finding the AOS. So -b over 2a is -4 over 2, or -2. So there's my axis of symmetry. On that axis of symmetry is my vertex, so I'm going to plug in. We get -2 squared plus 4 times -2 minus 3. So 4 minus 8 minus 3. -4 minus 3, -7. So my vertex is at -2, -7. 3, 4, 5, 6, 7. And then I'm going to use my y-intercept, -3. So -3 is down here, and then I'm going to reflect it to this side. Now before I draw my u, I got to make sure if it's a dot or a solid. So because it's just greater than, it's going to be a dotted line. And then when I decide where to shade, I'm just going to plug in. 0, 0 is not a point on my graph because I knew I was at 0, -3. So that's an easy one to plug in. So if I plug in 0, 0, everything with an x goes away, and I'm left with 0 greater than -3, which is true. So that means 0, 0 is a solution, so I'm shading inside my u. And there's my inequality.